For P3, hopefully you have already read through this and tried to fill these in for you. So I will be just going through this pretty quickly. Things that I'll point out, the standard form of a polynomial, as you know, is when it's written with the descending powers of x. So the higher power should be first and so on and so forth, and go down from there. So if we rewrite this polynomial in standard form and then go through those terminology, you should have negative 4x cubed first, and then plus 2x squared, minus 2x, and plus 7. So that would be following those directions. The degree of this, also known as the order, is just asking you for the highest power. So the degree or the order of this polynomial would equal 3. Again, it's the highest exponent, so we've got x cubed. The leading coefficient, if I just abbreviate that, the leading coefficient would be negative 4. So again, just a number in front of that highest powered term. And then the constant would equal the 7, the one without the variable. Stating why these would not be. So the second one, not a polynomial, basically because of the root symbol, because you would not have those, like it says, integers, so non-negative integers for the exponents. So basically the root symbol is the issue here. And likewise on the right hand side, actually number 3, we would have a problem because of a negative exponent. In other words, that would mean x would be in the denominator. And again, the exponents are supposed to be non-negative integers. Okay. All right, and then we should know monomial, binomial, trinomial, just talking about how many terms. And then if we ask you what's the degree of a constant term, hence like the 7 above, well, you hopefully think of 7 above. Notice we had x cubed, then we had x squared, then we had x to the first, so this would be x to the 0. Okay, so this would really be 7x to the 0. And so, because remember, anything to the 0 is 1, and 7 times the 1 would be the 7. So what would the degree or the order be? It would be 0. Okay. And then subtracting the polynomials, hopefully you're just thinking that you would just be distributing this. Again, you should always be showing work, so we're not just going straight to an answer. We should be doing 15x to the 4th minus 18x minus 19 minus 13x to the 4th plus 5x minus 15, distributing that negative sign, and then combining like terms. We would have 2x to the 4th, and then minus 13x's, and then minus 34, looks like. Okay, that would be our final answer there. Next, multiplying polynomials. So to multiply two binomials, you may have used FOIL in the past. We really are in upper level math. We really need to start using that word that we are distributing. Okay, I think most of you guys have been using that with me anyway. So keep that up. We are really distributing. So if I give you something such as a binomial, right? 2 terms by 2 terms, so x plus 2 by x plus 3, and ask you to multiply them together. Then if you distribute the x to both terms here first, you should be getting the x squared plus 3x. And then if you take and multiply, distribute the 2 to both terms, you'd have plus 2x plus 6. And then combining like terms to, of course, get your x squared plus 5x plus 6. Okay, so just keep with that. vocabulary. And then, of course, knowing certain special products makes some of the multiplication problems much easier, guys. So we should know these names. So sum and difference of same terms, right? So this is sum, the addition, difference, the subtraction. And when you see sum and difference, that should multiply out to be a squared minus b squared. You should also know that both ways, okay? We'll be getting to that very soon, but we're talking about right now just the multiplying. So we're talking about that going forward. And then squaring a binomial. Again, a few of us have looked at that and said, can't I just make that a squared plus b squared? And here's why that answer is no, once again, because you're forgetting that it really multiplies by itself. You would have to write it out, and most of you are forgetting that middle term, okay? That if you combine those middle terms, you would get those. Okay, I'm more of a fan of just actually writing them out and multiplying them, but you can memorize those too if that's going to help you. Likewise, the cube of a binomial, up to you guys if you're going to just go ahead and memorize this, and I'm okay with that. However, I think you guys should also probably know binomial expansion, and binomial expansion I think will help you for any power, okay, not just cubed. This would make it a whole lot faster. So this is just something extra that I like my students to know, okay? So let's say that I was going to ask you to expand a plus b to the fourth power. All right, you're going to start with the first coefficient is always a 1. Then you're going to take these two terms, and by these two terms I mean the a and the positive b that's inside. And you're going to put them in parentheses. So always put the a first, put the positive b second, and whatever this power is, put that full power for the first one. Now the next pattern you need to know is that the power on a and the power on b must add up to this original exponent. Okay, so 4 plus 0 would give us that 4. Next, we're going to say 4, this 4, times this 1 is 4, divided by 1, since this is the first term, will now give us 4. That's your next coefficient. Again, put the a in the parentheses, the b in the parentheses. The first exponent will always go down by 1. So the a to the fourth now becomes a to the third. Likewise, the second exponent should go up by 1. The 0, b to the 0, will now become b to the first. Don't forget the pattern that we should always be checking. These two have to add up to that original exponent. And 3 plus 1 does add up to 4. Okay. All right, got to change colors on you again. So now we need to say that 3, same process as last time, the first exponent times that coefficient. 3 times 4 is 12, and 12 divided by 2, because of this being the second term, would give us 6. So now that's our next coefficient. All right, you know it's a and b. Hopefully you're seeing the pattern for a, that's going to go down by 1, so now it's going to be squared. Hopefully you're seeing the pattern for b, that's going to go up by 1. Don't forget that 2 plus 2 does equal 4. Okay, ask yourself how you're going to get the next coefficient. Hopefully you're thinking that power times that. So 2 times 6 is 12, divided by, well, this is the third term of that expansion. So 12 divided by 3 is again going to give us back to 4. And now a and b. A should be to the first power this time. B should be to the third power, because 1 plus 3 equals the original 4. Okay, one more time. Next coefficient will be this 1 times this 4, which is 4, divided by 4, since that is the fourth term in this expansion, and that will give you 1. So again, that's the new coefficient. There's a, there's b. A would now be to the 0, and b would be to the fourth. Okay, and A is exponent of 0 and B is exponent of 4. 0 plus 4 equals 4. So how do you know you're finished? Well, one, notice at the start, right, A has the full power of 4. And at the end, B, the second term, has the full power of 4. So that's how you know you're finished expanding. Okay, here's some other patterns that you should recognize. Notice coming in from the two ends. Notice here on the right and here on the left, both of these are 1s. If you come in one term, notice both of those are 4s. And if you kept following that pattern, it should make a pattern. So for instance, if you had like 1, 4, 6, 3, 1, you would know something was wrong. Okay, now maybe some of you guys are saying, "Ooh, I might recognize some of those numbers, 1, 4, 6, 4, 1." And maybe you should. Okay, they are the coefficients from Pascal's triangle. Okay, they are the coefficients from Pascal's triangle. And so maybe some of you guys have seen that before. Okay, and then of course we have to go ahead and finish cleaning this up. So I need to get us a little bit more room here. All right, go ahead and take that away. And then the simplification. So you want to look at that step that's written right there for patterns. Okay, that's the pattern part. And then of course you're going to simplify them. So here, anything to the 0 is 1, and then times 1 and a to the 4th. Of course, we're not going to put the 1 in the front. Plus, we're going to have 4a cubed b, get rid of some of the parentheses, plus 6a squared b squared, plus 4ab cubed, plus a to the 0 is 1 times the 1 is 1. So we're looking at just plus b to the 4th. Okay, that would be your expansion. I would prefer you could do that. That is a whole lot faster than having to write out this guy 4 times and multiply it by itself. Lots of room for error there. Okay, so why don't you try the binomial expansion on number 5. So if you want to turn off the video and try that yourself, I think that would be a good test for you. And then let's see where we can go from there. All right, so again, you have options. You could multiply this out by itself 3 times. Okay, that's an option. I prefer that you say, I know the first coefficient is always 1. I'm going to put the first term of 2x in parentheses, the second term in here of -3 in parentheses, and then we'll go with our powers. Okay, so the power should be the full thing for the first one, and 3 plus 0 would give us 3. Next coefficient would be, hopefully you're doing 3 times 1 divided by 1, which would give us 3. Put 2x and -3 in parentheses. This will go to 2. This will go to 1 plus. Okay. Next term you would be doing 3 times 2. That 2, that 3 divided by 2. So 2 times 3 is 6. Divided by 2 is 3. Put 2x in parentheses, -3 in parentheses. And this is now a 1. This is now the 2. Okay. Once again, 1 times 3 divided by 3. So 1 times 3 is 3, divided by 3 is 1. 2x and -3 in parentheses. This is now to the 0. That now has the full power. We should know we're done. I am recognizing those patterns of the two ends, the left and the right coefficient are 1, move in 1, and they're both 3s. Okay, so I am confident that I am on my way. That's the step again that you've got to look for patterns. Okay, now you got to simplify. So looks like -3 to the 0 is 1 times the 1, and 2x cubed. Well, if I cube the 2 and the x, I would have 8x cubed. That would be simplified of that term. And then I'm going to go ahead and do the -3 times the 3 and say -9 times, I don't want to do too many things at once. If I put this in there, I'd have 4x squared. Okay, and then plus, well, this squared is going to make that +9 times that 3 is going to give me 27 times 2x, because it's to the first. And last but not least, negative 3, so negative cubed, it will be negative. I'm going to get negative 27 times that 1, so I'm going to go ahead and make this negative 27. And then 2x to the 0, anything to the 0 is 1. Okay, the last step then is really just clean it up completely. So I'll have 8x cubed minus 36x squared plus 54x minus 27. Okay, I guarantee those 2 lines of work is a whole lot shorter than multiplying that out 3 times. Or especially if you think about something, if I raise that to something like the 12th power, a lot of writing on that first step, but it's still going to be a whole lot easier than multiplying something out 12 times. Okay. All right, 6, they're giving us a little hint here of trying to use grouping to make it easier. And by that, we mean, hopefully, I'm going to put some brackets to make it a little easier to see. Let's group the x plus y together, plus 1, and group the x plus y again together, minus 1. So I didn't change anything, just how it looks. Okay. And then hopefully, if you are multiplying these together and thinking about what we did above with the sum and difference of the same terms, hopefully you see those as the same terms. You've got x plus y in the front of each of them. You've got 1 in the back of each of them, just 1's plus and 1's minus. Then hopefully you would realize that you're going to get, just like above, you're going to get x plus y quantity squared, which is what you would get from multiplying these two. And then minus 1, which is what you would get from multiplying these two. Now, why did we leave out the inside and outside? Think about it, guys. If you're distributing, wouldn't this produce the exact same thing as this, but just the opposite sign, and they would cancel, right? Kind of like that concept of conjugate that we were doing for stuff also. I will just say that might be the answer that's given to you, or I will say, or if expanded more, okay, because I don't know necessarily what problems you're going to be looking at and what it's going to say. But if you went ahead and expanded that out, think about squaring this term then. If you square that and combine your negative 1 with it, you would have x squared plus 2xy plus y squared minus 1. Okay, I'm going to circle both of those. I prefer you actually give me the top answer, okay, that top answer, because that's really the pattern that we're looking at. All right.